All right. Before we get into microservice testing, are there any project-related questions that I can answer? Yep.
Can we have access to EC2 instances? Well, it was just a random thing I was thinking about earlier.
Yeah, I don't think so. I think we've given you access to ECS, which runs on EC2, but not EC2 directly. Cool. Yeah, Luke.
I'm just double checking that in the standardized data there's a duration field. Is that duration how long it's been since the data was updated in the data lake?
Is the duration how long it's been? I couldn't tell you, to be honest. I'm not across any of that side of the course. That's a question for the forum, and either Alan or Fethy can help out with that. Cool. Anything else? No. Awesome. Before we start, I wanted to briefly just talk to, I think, some feedback around, I guess mainly around, like, you're doing a sprint one, and we've had lots of conversations in the lectures, and I know you've been having plenty of conversations with your mentors about, what actually do we need to do, and where does this sort of fit into the rest of the course? And it's kind of interesting because not only is it the first time we've run this, but it's sort of a point where you and your mentors as well kind of don't fully understand exactly everything that's going on. And I wanted to talk to that briefly because, like, normally when you build some sort of application, you'll often build, you'll say, okay, I'm going to have this website, and maybe you're building slides, for example, and you say, okay, we're going to make a application where people can create slide decks, and it's going to be web-based, and it's going to be interactive, and you start with the sort of end use case, and maybe come up with the UI design, and then sort of go from there. Okay, how are we going to power that? Right, we'll write a series of APIs in Java or Python or C++ or whatever, and then you go and build your microservices from there. Whereas what we're doing in this course, for a bunch of reasons, and kind of what we did last year as well with the invoicing, right, is you start with the APIs and then you move to the front end as opposed to starting with your end use case. What that means, and I think I've said this to a few groups that are doing import services, is that if you're building an import service, you're not directly serving a user, right? But you're providing them some value kind of secondhand, right? Like you might go and collect some data from Yahoo Finance or from the BOM, right? And then that goes into the S3, and maybe that's all your service does. And that's not directly providing the user value, but it's still providing value because someone can then use that data and produce a report, right? And that's how the ecosystem fits together. So that's one thing. And I would say, like, I think most groups are fine, but don't worry too much. Like, we'll come out with the info about Sprint 2 and Sprint 3 next week. And don't get, I guess, too hung up on like the sort of destination fever aspect of it, where it's like, we need to figure out, exactly how everything fits in and what's going to happen in the future. Because everything you need to know for Sprint 1 you've got, and all of you are doing a great job with that. So, and one other thing that I think is interesting is that we're taking what's called a platform approach. So when you build an API, and we talked about this briefly with GraphQL and stuff, and problems with REST, is that traditionally, you have here's your API, and maybe that's a back end, right? And then you have a front end application which consumes from that API. And in many respects, your back end is built to serve your front end, right? But as we start to take what's called a platform approach, right? We're adopting platform as a service where we create software that other people can use to create more software to deliver further value. So, example is VLab, right? That's platform as a service where you get given an operating system, a place where you can run commands, and then you can write more code and do more stuff. Any API is an example of platform as a service in the sense that someone can call your API and use it to, like I take the APIs that we use to create your Jira boards and Confluence spaces, right? They're made by Atlassian. I write a bunch of Python scripts that call those APIs, and then that's how we provision your Atlassian toolchain. And then, the Jira and Confluence front end will also use those APIs, and they'll use those in different ways. We'll talk about that when we get to contracts in this lecture. But my point is that your API isn't a one one size fits all. Sorry, it is a one size fits all sort of thing in the sense that you build a front end and that will consume from your API, and then someone else who might be completely different also will consume from your API, and your API needs to be able to be generic enough that it's useful for both, right? So not anyone, but anyone who wants to use your service can use it as a platform to leverage off. And that's what we mean by you're making platforms. And if you start with the end and build your API just to get to the end, then you sometimes maybe make it a bit too specific. So that's one of the reasons why we go with this approach, is that we want to encourage this idea of working as this one big platform company. And there's talk in the industry about technology companies as they evolve will just become sort of platform companies where everyone sort of builds different abstractions on top of one another that other teams can sort of further leverage off and build on. And you kind of all understand that as you're working with each other and leveraging off each other's APIs. Does that make sense? That was quite a long-winded ramble. But I hope that gives some context around what we're doing in Sprint 1. That was all I had to say. Let's get into microservice testing. We've got half an hour. Okay, so we're going to briefly recap on testing and some different types of tests. I know that you've covered this at a few points in your degree. I'm going to talk about different types of tests in relation to microservices in particular. We'll talk about pre-production versus in-production testing. We'll talk briefly at the end about chaos engineering. And as we go throughout this lecture, we'll talk about what it means to define a testing strategy and how you as a team and you as a cohort are going to need to figure out a testing strategy for Sprint 2. Okay, so recap on test design. It's not enough for our software to be correct, right? It's not enough for our software just to work. Because let's say you build a website, let's say you build the slides app and you didn't write any tests and you deploy it into production and it works and you're like, great, my software works. That's not enough, because then you make a change and then everything breaks and you don't have anything that's telling you that your software is broken until it arrives in production. So we want our software to be correct on purpose, or we say verified, right? Software verification. We want to do what's called shift left, which is where we move risk earlier in the development process. So instead of finding bugs when they are in production, where you've got live users actively using your software, let's catch the bugs at compile time, right? Like using a strongly typed language. Let's catch bugs at when we do dynamic verification with our unit tests and integration tests. And then the last point that's related to testing is the concept of verification versus validation. Does anyone know the difference or can remember the difference? No one? Yeah.
Verification, like actually make sure that you look to validation focus checking that it's correct.
Not quite. They're kind of testing like at different levels of abstraction. You can think of sort of verification as testing your solution or your design, and your validation is testing your requirements. But that's one way to think about it. There's a little saying though, which I think is talked about in 1531. Nope. Okay, that's all right. No one remembers it. Verification is, did you build the system correctly? Did you build the system right? And we can guarantee that through passing unit tests, through performance tests, through a variety of tests. And then validation is, did you build the right system? Did you build something that was useful for people that people actually wanted to use? Or did you just go and build like a slides application that no one wanted? So that fits into testing as well. And the stuff that Chris has just talked about with feature flags and advanced deployment fits into that validation category. Okay, now there's the thing about testing. Like if you go and look up types of tests on the internet in software engineering, there will be a million different names for, and every website, every article, every book you read, every company will have their own unique definition for every single type of test. So I'm just going to talk about some broad ideas. I'll give them some labels as names, but you can just think about it more conceptually. And like often you'll come across stuff and go, oh, okay, I've come across this before, but it's just got a different name. The first thing I'm going to talk about is the Agile testing quadrants. I think it's a book called, I think it's just called Agile Testing, where during the Agile boom, people talked about testing and test-driven development a lot, and they came up with this framework, which is sort of 4 different broad categories of tests that we write when we practice Agile. So the first type is acceptance testing, which used to be a lot of manual testing, where you'd get someone, you get a QA person who'd go and sit down and use your software and go click, yep, I can log in, yep, I can create a slide deck, I can edit the slide deck, and they'd do that manually. Now more and more we use automated tooling to essentially go through that very, it's a very tedious, step-by-step process. We just get the computer to do that for us. So that's all automated. Then there's unit or integration testing. It's called unit testing on the diagram, but I term it as sort of functional testing because, as we'll look at in the next section, there's a bunch of different types of functional automated tests. And you're all used to that. You've been writing them for 3 years on your software. The next type is exploratory testing. And this is essentially testing that you can't really do with a computer because it's not, let's just follow this, recipe step by step. Okay, click, click, click. Yes, this works, tick a box. It's getting people to just try and break your system. Just go in, try and break stuff. Put in random stuff. Put in some SQL to try and pen test your system. Put in random bits of data. Anything that can pick up problems that your automated test wouldn't otherwise. And then the last form of testing is called property testing, and this is things like testing performance. Testing, is your service actually just alive? Like ping a health check endpoint. Testing latency, network connections, all of the other more technological aspects that aren't necessarily functional. So there are the 4 quadrants, and then there's sort of different, I guess we call it sides to the diagram. So the top 2 are business facing, right? They're the things that our customers will see and our customers will experience if our product's not working. The 2 on the left, sorry, actually I'll go to the bottom next. The bottom 2 are technology facing. They're more about what the engineers will see and work with day to day. The 2 on the left are what's called support programming, which just means we can deliver software with confidence and minimize our risk when we're delivering software. And then on the right is critiquing the product, which basically just means, can we improve our product or software in some way? Cool. Okay, so that's the testing quadrants. Now we get on to the testing pyramid. When we structure tests in microservices, there's this idea that our tests sort of form this pyramid, where at the bottom we have a whole lot of unit tests, right? That's in the bottom because there's the most of them. And then as we work our way up, we go up the chain of abstraction, and we also get fewer and fewer tests as we go until we get to the top of the pyramid, which is end-to-end tests. End-to-end, as we'll talk about, is very loosely defined, but you can kind of think of it as being similar to an acceptance test. It's using the system, as a user would in production, from start to finish, from end to end. So, as you go up the pyramid, the scope of your tests increase in that you are testing more in a single given test. As you go up the pyramid, the tests become slower to run because you're testing more. They become harder to isolate. So if an end-to-end test fails, it's very hard to, it's not impossible, but it can be harder to pinpoint down what is the exact thing that went wrong that caused the test to fail, right? Because it's just testing so much stuff. So the isolation's worse. But if the test passes, you have more confidence that your software is actually working. Again, because it's the same as how your users will be, or closer to how your users will be using your software in production. And they're also harder to write, again, because you've got lots of moving parts. You have to orchestrate a whole bunch of services to all work together and do that in a test setting. The opposite is true when we go down the pyramid. So, if we're looking at unit tests, they're really fast because they're just testing one tiny thing. It's much easier to isolate. And this is the idea of a unit test, right? Is that you write a unit test, the unit test fails, you know exactly where to look because it's only testing one thing. Because we're testing less, though, we get less confidence. So your unit test passes, you're like, okay, that's cool. But having a bunch of unit tests isn't enough to guarantee that your software is correct. And then last of all, of course, it's easier to write because we're not testing as much. Now, again, I've included another diagram which is slightly different from the pyramid one from above. If you look up testing pyramid on the internet, you'll see heaps of variations, but they all kind of mean the same thing. One other little aspect of it, they have this cloud in the top, which means manual testing, which is sure, I guess. So that's another representation of our pyramid. But an important anti-pattern that I want to point out is, well, they call it a snow cone in America, but we call it ice cream here. The testing ice cream. So instead of having lots of unit tests and then having fewer and fewer tests as you work your way up the pyramid, you instead have a ton of manual tests or a ton of end-to-end tests and then very few unit tests. As we'll see, that's kind of not great because it's much harder to maintain, and you don't get as much isolation. Where you want to be able to have every single piece of business logic covered by a unit test, and then as you work your way up, there's less and less. Any questions so far? No. Cool. Okay, so we're going to kind of work our way up the pyramid, starting with unit tests. Now, you've all written unit tests in some form before. What do we mean by a unit? And the answer is really, well, it depends. You could define a unit as being a single function. You could define it as being a single class, which has a series of methods and pieces of data associated with it. You could define it as a single feature, or as a single user story even. You could define it as an API endpoint. It's really up to you. The idea, though, is that you're testing one thing, and every bug, this should say every bug in business logic, in the logic of your application, that is detected, you should be able to reproduce in a unit test. So if your software has a bug in production, right, like I don't know, there's some mathematical error, right, where it's charges the user 10 cents extra for the slide subscription. You should be able to say, okay, here's the bug in production. I can now write a unit test which is going to fail to replicate that in my test suite. And then when you fix the bug, the test passes, and that's how you know that you fixed the bug properly. It's also very useful in test-driven development when you're writing individual features. You write your tests, implement to pass the tests, and those tests will cover that one particular feature or class or function. Now, there's two types of unit tests which achieve different things. The first type is a solitary unit test, and this is like, if you think back to year 5 and high school experiments, in your experiment, you've got I can't say that word. The independent variable, which is the variable that I choose to change, the dependent variable, the thing you're measuring, and then everything else is a control variable. And you want to do the kind of a very similar thing when writing unit tests, where the only thing that is the independent variable is the piece of functionality you're testing. Everything else is the same. So any dependencies, any other functions that or services that your microservice relies on, they're controlled, they're consistent, and we do that using a mock or a stub. Now, have people used mocks before? A little bit, not really. Okay, so a mock is basically where you say, okay, like here's my app, and here's something that it relies on, maybe another microservice. And when I write a solitary unit test, instead of having the real app there, what I'll do is I'll switch it out for a dummy app. And the dummy app might just, return 1 by default. So, maybe instead of making a network call to another microservice, it just calls this other function. But your app should be designed in a way that it doesn't realize that. And good mocking frameworks allow you to just sort of substitute out the real thing for a fake dependency. And that allows you to create a stub. And then a mock is when we actually verify a call was made to the stub. So you say, okay, I'm going to use this function which pushes some data to an S3 bucket, and then you mock the S3 bucket with just a fake dummy class, and then there's inbuilt. Then different mocking libraries have this. You can say, did you actually make the call to the S3 bucket? And if it doesn't, then the test fails. Now, this actually requires knowledge of how the function works under the hood, which is why it's a white box test. But it's useful to make sure that the only thing that you're changing is the business logic. Yes?
Question I was have is, let's say that your API, like inside of your API, you make a GET request to another API, right? When you make that test and you were talking about the dummy API, deeply ingrained into your API to pull it, make a GET request. You know what I mean?
Yeah. So the question was, if you're like, let's say in your source code you make a HTTP request to another API, like you're doing the bomb, right? And you say you make a HTTP request to the bomb, and you say, well, I can't stop that because it's literally part of my code. The answer there is your code is too tightly coupled in that case. So you need to find a way to separate interface from implementation. And this, sorry, without going into too much class-based stuff, right? It's like if you have maybe it's an object, right? Like called weather, and that's a type weather. It's a class. But this weather class might actually just be an interface. Here's our interface, and then your real weather service will implement that interface and provide all the functions. And what you do is you get your dummy service to also implement the same interface, so that you can just swap them out, and your service doesn't care. This is called dependency injection, where your dependencies comply to an interface, and then you can just inject whatever you like that matches that interface. I can give some, on the forum, I can post some stuff about dependency injection. It's a super commonly used pattern. We probably need to talk about it in 2.5.1.1, to be honest, but I think we just ran out of time. So does that answer your question?
Yeah.
Yeah, cool. So dependency injection is how you you essentially take out those dependencies and make them comply to an interface. Cool. I'm running low on time, so I'm going to speed up. It's fast, it's more isolatable. We talked about easy to write. The bad thing is it's often very brittle, right? Because it's a white box test. You're coupling your test to your implementation, and there's less confidence in the correctness. So the other type is sociable unit testing, which is where the test is black box, and instead of mocking the downstream services or classes, we actually use the real thing. They can be slower to run because you're making more network calls, harder to isolate because maybe instead of you're testing your function, but if there's a problem in the downstream service that your function is calling, then the test might fail, but not because of your function. Again, you're just not controlling as many variables. Okay, next level up in the pyramid is called contract testing. Now, what's super interesting, if we go back to what I was saying at the beginning about how, let's say we've got the Atlassian API we use to make the Jira boards and the Confluence spaces. And so one of the clients of those API is me, and then one of them is the Jira front end, for example. And both of them use the API. But the thing is, we won't always use the API in the same way. Which means that when I use the API, I form a contract with it, right? I say, okay, I will give you some data in this format, and you will give me some data in the return format, and you'll also create some, Jira boards and Confluence spaces on the side. So we define the preconditions, the postconditions, and the invariants, which is, expectations of input and output data structures, any side effects, and this is all part of design by contract. So that if I, as the client, don't meet the preconditions, then the application isn't sort of, obliged to work necessarily. Similarly, the application's job, right, the producer's job in this case, is to always, make sure that it's working and that it doesn't break. And we talked about this with, when was it? That's right. We talked about it with semantic versioning, right, back in the dependencies lecture, where if you create a new version of the software that isn't backwards compatible and breaks the Liskov substitution principle, then downstream consumers of your API will be affected. And this is what contract testing tries to mitigate. The problem is, like, if I use your API and then the API changes, how do we know that the contract that we have has been maintained? Now, the point I think that's the most interesting with this is that even though, like, me and the Jira front end, we're using the same API and it has a single interface, we still have a different use case for it. And as a result, we form a different contract. So what I mean by that is, take this diagram here, where you have a producer that's just like an API, and then we have 3 consumers who consume from that producer. And then the first consumer, A, it only uses the ID and the name field. The second consumer, B, uses only the ID and the age field, then consumer C uses all of them. So as a result, they each form individual contracts with the producer. So when we write a contract test, which is done on the consumer side, we say, well, do all the things I need to satisfy my, our side of the contract, are they fulfilled? And everything else, like you might have 50 functions in the API, but Nick only uses 3. So Nick's contract test is only going to test those 3 things. Which means that when we make a new version of the producer, like let's say we wanted to get rid of this name field and convert it to like a full name, for example. So I make my change, I modify my interface, and then all of the contract tests run, right? A and C, their contract tests will fail because we've broken the interface, we've broken LSP, but B will pass. And this will all form part of my CI pipeline so that I know before I roll out that change to A, it's going to go, hey, A and C, 2 people who depend on your service, they're going to fail. That's essentially what I've said here. A contract test allows to verify if an API still fulfills its agreement, avoids regression. Each consumer has its own set of contract tests. And then this is another interesting point, is that the sum of all the consumer contract tests define the overall service contract. You can use tools like Pact for easy contract testing. Now, one other important thing with the contract stuff is that in large organizations, dependency is a big problem. Like it's hard enough to work in one team, just with other people, right? In the sense that, you have to talk to other people and listen to them and do all the stuff that, requires a concession and trade-off. This is like, you can't just be working, like a code monkey 24/7. And then you sort of take that and put it on another scale, right? Where you now have teams having to work with one another to figure out, what's going on with this microservice ecosystem. And you're all doing that firsthand with the project, right? And this form of contract testing is a good reminder of Conway's law, which we covered back in week 1, and says that your architecture will mirror the structure of your organization. And I was reading something the other day, which I thought was super interesting and I wanted to share, which is that, your traditional like front end, UI, application logic or business logic, and then your infrastructure, your database. And this is our sort of typical kind of 3-tier monolithic application, or there's some variation of it, right, that you're all used to. The reason this came about is because what companies would do is that they'd get all of their front-end developers and put them in a team. And they'd get all of their back-end or Python developers and put them in a team. And they get all of their IT people or their infrastructure people and put them in a team. And so as a result, that's how their architecture ended up, which I think is super interesting. So when we write contract tests and then you change your API, it's too hard for me to say, well, every time I change my API, I need to contact all the consumers of my API and say, hey, in this team I'm changing this, hey, in this time I'm changing this, because like people leave, people get made redundant, as seen by the latest round of tech layoffs. Just communication is hard in general. What if your other team that relies on your services is in Poland and is 12 hours behind? So instead, we just have it. We automate all that, and that you get notified when you might change your service that will cause a breakage in another team's consumer API. So it forms a discussion point between teams. Blah blah blah. I said anything else, and allows us to maintain backwards compatibility. All right, integration testing. Got 8 minutes. Integration testing just means testing more than one thing. Again, it's one of those super loose terms that everyone has their own definition for. We can test horizontally or we can test vertically. We want to be able to catch a web of dependencies to make sure that anything that wasn't caught by the unit test is picked up. But then if we catch a bug with the integration test, we need to rewrite that as a unit test, generally, if it's in the business logic. What integration tests and microservices do really well is test the glue between components, is one way to think about it. So they cover basic success and error paths. These are just sort of 2 categories. They're not the only categories, but like gateway and persistence integration tests, just check, again, the glue between maybe two different services. Are you providing the right request and response shape? Are you providing the right HTTP headers? Is the connection between the database and the application layer working? What happens when things like timeouts occur? What happens when one service just isn't down or it's gone offline? So they're useful, but again, hard to isolate. They can fail for more than one reason, and they can often be quite technical to write. Okay, component testing. Again, it's one of those very loosely defined terms where it broadly just means a group of microservices working together to deliver some form of feature and to deliver some sort of coherent user story. I won't go into a huge amount of depth on it. The only difference between component and end-to-end testing is that you just mock more stuff in components. So often we'll mock databases, third-party services, like your APIs that you're querying for import services. And again, it's very loose and pertains more to massive ecosystems where you have 20 different services, and let's test 5 of them working on a single flow. And the last type is end-to-end testing at the top of the pyramid. And this is, again, you can kind of think of these as being acceptance tests, where you test everything from start to finish, from UI, go all the way to the database and back, and make sure that the system's working as expected. You can use tools like Selenium, which do the role of be that person that clicks on the buttons on the front end and makes sure that you can log in. They're often hard to write, they're hard to maintain. Ownership can be a big problem, because if you have a series of end-to-end tests that cover 20 different microservices, or 5 different microservices, and each of those is owned by a different team, it's like, well, who's the owner of those tests? Are they just a free-for-all? Who maintains them? Who's the one who deals with stuff if they break? So those are just kind of hard questions that organizations have to deal with. They can also be less deterministic in the sense that they require a lot of orchestration, a lot of moving parts. So if one test fails, maybe it was just because of some bad network error. And then does that stop your entire CI pipeline? Does that prevent you from deploying? Which leads us into the next question, which is, well, when do you run end-to-end tests on a deployment? Do you run them before you deploy the service? So you get your new service and then all the other old services and then run them together? Do you run them after deployment? Open question. Again, here's a picture. Cool, I got 5 minutes. So this is all pre-production testing. But today, more and more companies will test their code in production. Now, technically, all software deployment is testing in production, right? Your software is constantly being tested as it's used. But we want to sort of formally verify stuff in production, because that's where our best monitoring is. That is where our best observability will be, because that's where you'll set up dashboards and metrics to test how your software behaves in production. We get to work with real life data instead of dummy data that we've constructed as part of testing. And we just, as a result, get exposed to cases that we otherwise wouldn't have thought of, or otherwise just wouldn't have anticipated. So here's some examples of tests that are run in production. You can have things just as simple as a liveness test, which just pings a health check endpoint that says, is this service actually alive and up and running? Performance tests, Greg just talked about that in depth, and running benchmarks on our services. Someone asked me what smoke tests were a couple of weeks ago. I researched into a bit more since then. They're just kind of very, very simple course tests that check, just like a sanity check to make sure everything's not completely messed up. So does the program run? Does the UI open? They're often very fast to run, and you run them as soon as the deployment takes place. And then lastly, feature flags, which Chris has talked about in length, used for in-production validation. Now, there's many other types of tests. Again, Google types of software tests on the internet, and everyone will have their own gospel, list of all tests with their own definitions. But some broad categories: volume or stress tests, which is where you just put the system under a large load and see how it copes. Soak testing. One method of deploying software is that you start with, you do it in your local testing, then you merge it into master, and then that will deploy it into a staging environment where it can soak for a few days or a few hours. Often that staging environment will be, like for example, at Atlassian, we use the software that we write that's the latest cut from master. That's a technique called dog fooding, which is where you eat your own dog food. That's disgusting. I don't know why it's called that, but essentially it's like you use your own software that you've built for your purposes in the company. So, that's a way of testing it, right? If there's any problems, then you pick it up, like you as the programmer have to deal with that rather than it reaching your users. So that's called soaking. Penetration testing, that's for done by security engineers to find flaws in the security of your application. Compatibility, so things like, is your software backwards compatible? What about compatibility between different browsers is a huge thing for front-end applications. And then, of course, regression testing is just, all tests function as regression tests to ensure that if you make a change, then there isn't a regression of functionality anywhere. Okay, last but not least, got 1 minute. Chaos engineering. It's a practice of proactively finding vulnerabilities in production systems. So what Netflix, who came up with this, would do is that they would literally try to break their software during business hours. So they'd say, okay, let's take out this server, and then make sure that their software can cope with those sorts of problems. So that instead of someone else finding it out in production or some malicious attacker coming and taking them down, they do it themselves and then learn and mitigate future problems. Okay. Any questions? Nope. Cool. So I'll talk about Sprint 2 next week. We have, just to get you excited, we have more guest lectures, which will be around leadership, individual behavior, and culture. And then I'll talk about Sprint 2. This will be next Thursday. The Sprint 2 spec will come out probably over the weekend. And there'll also be some more information on the portfolios, which your draft portfolio is going to be due end of next week. They don't count for any weighting, but you'll get the chance to give each other feedback on them. So if there's no other questions, then feel free to chat to Greg or Chris for as long as they're around. Otherwise, good luck for Sprint 1. Post on the forum if you've got questions, and I'll see you next week.